Hey everyone. Today I will be going over our final project for ET 102, which involves using provided equations to find the amount of time yellow lights and red lights must stay on in a given intersection. We need to make sure red light time gives drivers enough time to clear out of the intersection, and the yellow light gives ample warning to cars that a red light is coming soon. We will use the equation y in seconds equals t plus 1.47 v divided by 2a plus 64.4 g to find the yellow change interval. In this equation, t will be the reaction time of drivers, for which we will use 1 second. V will be the adjusted speed. This will be 7 miles an hour over the speed limit, as drivers generally speed. A will be the rate of deceleration, for which we will use 10 feet per second per second. And G will be the grade of approach, for which we will use 0. We will be using the equation R in seconds equals W plus L divided by 1.47 V, all that minus 1, to find the red clearance interval. In this equation, W will be the width of the intersection, which is noted on the example spreadsheet as either 90 feet, 120 feet, 150 feet, or 180 feet, depending on the intersection we're looking at. L is the length of the vehicle, which we will use 20 feet. And V, again, will be the adjusted speed, which is 7 miles an hour over the speed limit. We first need to configure our spreadsheet. We will set up the spreadsheet template to match that which is shown in the final project overview. And I have this shown here. This will include 4 different intersections of 4 different widths at 4 different speeds, as well as our constants V, G, W, T, A, and L. We need to calculate the yellow change intervals and red clearance intervals for each intersection at each speed. This can be done manually on paper with a calculator, but since we're using Excel, we may as well utilize the program to its full potential. So let's look at the spreadsheet. I have the spreadsheet here. Excel allows us to use functions and formulas within the spreadsheet to have the program do calculations for us. To do this, we will need to set up formulas for each cell that we need results for. When I click on cell I3 right here, we can see the formula that we use to generate the result. We start all formulas on Excel with an equal sign, as you can see here. And then we use the yellow change interval equation, but we swap out the variables for the cell numbers containing the variables we need. So T would be F3, V would be C3, A would be G3, and G would be D3. When we enter in our formula and click enter, our answer is generated. We can change the number of decimal places by right-clicking on the cell, choosing Format Cells, choosing Number, and choosing the number of decimal places we want. I've done this already here, and I'm choosing 2 for this project. We would then use the same formula for all yellow change interval calculations. We would just need to change to the correct row number for each cell. So you can see here, we have F3, C3, G3, and D3 on row 3. Here, row 4, we have these changed to F4, C4, G4, and D4, and so on. F5, F6, We would complete the red clearance interval calculations the same way, with W being in column E, L in column H, and V again in column C. After we create our formula in J3 up here, we can use that same formula for all the other red clearance interval calculations by changing the row number. So we have E3, H3, C3 in row 3. Row 4, we see E4, H4, C4, 5, E5, H5, C5, and so on. It's always a good idea to check your work, even if you're using a program like Excel. Small mistake can go unnoticed and will alter the final results. Choose a few rows and do the calculations manually on a calculator and make sure your manual answers agree with your answers produced in Excel. I've done this and my results do in fact match. Now we need to choose one specific intersection at one specific speed to incorporate into our Tinkercad stoplight. I'm choosing intersection 3, which has a width of 150 feet at a speed of 52 miles an hour adjusted. This would be a posted speed limit of 45 miles per hour. From my calculations, I have determined the yellow light must stay on for 4.82 seconds, and the red light must stay on for 1.22 seconds. We can choose any value we want for the green light, so I will choose 5 seconds. With the results, we can move over to Tinkercad to incorporate these values. Here you can see I adjusted the timing values in green and edited the orange text next to each to match the green times. So here is 1,220 milliseconds, which is 1.22 seconds, 5,000 milliseconds, which is 5 seconds, and 4,820 milliseconds, which is 4.82 seconds. When these here go low, that means that the light is turned on. When it shows high, that means the light is turned off. When we hit the start simulation option at the top, we can see that the stoplight works properly according to our specifications. It starts with both red lights on, turns one side's green, then the yellow turns on. They both go back to red, then the other side green turns on, then the yellow, and then back again to red. Thank you for following along with me as I demonstrated how I found the yellow change interval values and red clearance interval values, and then incorporated them into my stoplight built on Tinkercad. Excel can be a very helpful tool when trying to solve problems and organize data. I hope this was informative and valuable.